This is Geometry, Chapter 10, Lesson 4. And we're going to use parallel lines to make similar triangles so that we can solve for parts of a triangle. All right, so this is a rough rendering of the picture on page 399. So ABC is the pyramid, and they're trying to figure out what is the height of the pyramid. All right, so they drew an altitude. An altitude goes from the vertex perpendicular to the opposite side. All right, so that's a right triangle. All right, and it divides that base into two equal parts. All right, that's 380 and 380. All right. Now, what they did was then they put a staff perpendicular, that's EF, your staff, perpendicular to the ground so that we can form another triangle. All right, so now we have, and then they drew these lines parallel to one another so that this line goes from C to F. So now we have triangle CDF. It is going to be similar to this little triangle EFG. It's similar because all of the angles are equal. All right, so look at this. We knew that those are both right angles. These two angles here, angle G and angle CFB, this angle right here, they are corresponding angles. All right, so now I have two angles that are equal. When I know two angles of the triangles are equal, the third angles have to be equal as well, because the sum has to be 180, so you have to be adding the same value. So we know that CDF is similar to EFG, so I can actually use proportions to solve for the height. It's geometry. All right, so let me label some of these sides. Let's see if I can get a different color here. All right, so EF is 6 feet. That's kind of light, isn't it? Let me try this orange. It's 6 feet. It's kind of light too, maybe the green. All right, so EF is 6 feet. FG is 8 feet. Okay, well, they can measure these. You can measure the height of the staff that they put down, the shadow that it casts. You can measure the distance from the base of that to the shadow that it casts. And then they knew the distance from the staff to the base of the pyramid, that was 260 feet. And from here to that line was 380 feet. So now we can use proportions to solve for the height. All right, so the height, which is the question mark, goes with the 6, the height of the staff, all right? Now the base side of this triangle is 8, and it corresponds to the 380 and the 260, which that total I went ahead and added was 640. So that's 640. Now I can use the proportions. We'll make this x over 640 equals the 6 over the 8. I can cross multiply to solve for that. 8x, 6 times 640 is 3,840. Obviously, it's okay for you to use your calculator, all right? Then I could divide both sides by 8. The height of that pyramid, the 3,840 divided by the 8 is 480, and I'm guessing it's in feet. I didn't look to see what it's feet, 480 feet. So you can actually use geometry and solve for the heights of something that you can't like reach up to with a measuring tape and measure it. Maybe when we get back, we'll measure the height of the poles in the parking lot, because we can use ourselves with our shadow cast and put the shadow of the pole at the end of our shadow as well, and use similar triangles to calculate the height of the pole in the parking lot. All right. Hopefully, it's like over a week away. I don't know if we'll be able to do that. So we're going to use similar triangles to solve for missing parts. We're now going to move back into proofs a little bit. But we can use similar triangles just like we did that side splitter theorem to be able to solve missing sides by using proportions. All right, so what makes similar triangles? So we're going to be given some information, and we're going to want to get to the place that says triangle ABC is similar to triangle DEF. This is going to be your statement. Your reason always has to be angle, angle. Because if you prove two angles are congruent, you don't need a third one, because you know that the third ones are congruent as well. If two angles of a triangle are congruent to two angles of another triangle, the third angles are congruent as well. All right? So look at the angle theorem on page 400. It says if two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. If they're similar, we can use those ratios to solve for missing sides. All right? So I have a couple of proofs that I want to walk us through since we're moving back towards proofs. And so we'll begin. It's always going to use parallel lines, all right? Okay, I'm going to erase this end. We're going to make these parallel. It's A, B, C, D, E. All right, here's given. AB is parallel to DC, and angle ACB, I think I can make that a C, CB is congruent to angle E. Okay, ACB is congruent to angle E. All right, remember, your statements, your reasons. I'm always, and here's what we're proving. I didn't even write that. We're going to prove triangle ABC is similar to triangle DCE. That's what we're proving. All right, that these two are similar. In order to prove that, I need two angles that are equal. So I'm looking for angle, angle. Well, I'm going to write my given statements, right? AB parallel to DC. Y given. Always, 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 always. Write your given statements. Angle ACB congruent to angle E. That's an angle. I only need one more angle. That is given. I just need one more angle. Looking at these parallel lines, I have corresponding angles here and here. Those are corresponding angles. So I can say angle ABC is congruent to angle DCE. Why? Parallel lines form equal corresponding angles. That's all I need is two angles, and now I've already proven it. Triangle ABC is similar to triangle DCE. Why? Angle, angle. All right, so now what are some ratios that I could write, knowing that these are similar? Okay, I've got to look at corresponding sides, because you're gonna have to know this as well. I'm gonna erase this. Let's write some ratios that we can know. All right, AB to BC. So AB to BC is going to be congruent, has to be equal to, because remember, this is just a dilation. ABC is bigger. It's a dilation of DCE. So the side that corresponds to AB is DC, so that's got to go on top. The side that corresponds to BC is CE. So that ratio would work. I could also say AB over AC, using that side, is congruent to DC over, now looking at DE. So I could use those proportions to solve for the lengths of sides. All right, now, what if this looked like the side splitter theorem? And this is M, N, O, P, Q. The only given statement is MQ is parallel to NP. And we want to prove that triangle QMO is similar to triangle PNO. All right, so I began by writing the given statements. All right, let me write statements, reasons. The first one is MQ is parallel to NP. The reason is given. To prove similar, all I have to do is prove, I simply have to prove two angles. All right, so these are, I can actually prove three. I know that when these lines are parallel, those are corresponding angles. All right, so I could say angle OPN is congruent to angle OQM. That's an angle. Why? Parallel lines form equal corresponding angles. All right, so that's one angle. Now, it's the whole is similar to the top. Angle O is in PNO. Angle O is also in QMO. So I'm going to say that angle O is congruent to angle O. And you already know it, huh? It's reflexive. Now I have two angles. I could have said this M equals N, but but I want you to see that O is in both the triangle in the top and the whole triangle. So you can always use that common angle that's in both of them and just say reflexive. Now I can say, I have this proven. QMO is similar to PNO. My reason always is going to be angle, angle. Now, I can say that any of those proportions are true. Let's just write a proportion. I can say, move it down a little bit. I could say that ON over NM is equal to the other side, OP over PQ. I can write any ratio is congruent. And it's going to be just like after we did congruence, the next statement was corresponding parts of congruent triangles are equal. This is going to be similar to that. The reason here is going to be corresponding parts of similar triangles. They're not congruent. They are proportionate. Proportionate. I wrote a proportion. So now we're going to have a new statement. Corresponding parts of similar triangles are proportionate. All right? They have the same proportion. So I could prove any of those portions. Okay, I want to do one more proof. All right, so I have this triangle, two triangles, right? S, D, U, T, W. Okay, it is given angle S is congruent to angle W. We want to prove that triangle SUV is similar to triangle TUW. All right, so we begin with our given statement. Angle S is congruent to angle W. S congruent to W. Why? Given. You can't see the top, can you? Okay. Well, I have another set of angles that I can know are congruent. This angle is congruent to that angle because they are vertical. So angle SUV is congruent to angle WUT. Why? All vertical angles are equal. I have an angle. I can say that triangle SUV is congruent to triangle TUW because of angle. All right, so towards the end of this lesson, you're going to have some proofs to do. So work hard on this, and I hope to see you tomorrow.